Okay, so Cloud Native Jenkins. My question to you, who has already read this blog post on Jenkins.io? Please raise your hands. Okay, so maybe the half of audience has already seen it. And if you haven't seen it, it's one of the key points to check on cloud native effort. And what we present today is aligned with this blog post, and that's what we are trying to show. So as a part of the vision presented by KK, there is a cloud native Jenkins solution. And this cloud native Jenkins solution has, so actually it's a general purpose CI/CD engine which is based on Kubernetes platform. It has low cost of operation, it's easy to use, easy to develop, and it supports infinite scaling. So all common properties which cloud native applications have. And obviously, if you want to build such solution from Jenkins, there are some changes need to be done. And we will try to present these changes. So we will talk about pluggable storage, about cloud native Jenkins, how we would approach that, what we need to do that, and we will show existing prototype and tools which allow building such prototypes. But yeah, probably we should start with cloud native SIG. So Carlos, oh, you don't have a mic? No. Okay. So Carlos is an organizer of Cloud Native SIG, and he will present it. Just a disclaimer, what we present today is mostly still under the development. So we are looking for feedback, and we are looking for contributors. In the end, we will show how to get that. And Cloud Native Special Interest Group, which Carlos will present, is one of the venues for that.
Thanks, Oleg. Yeah, so... No, I got the wrong one. Yeah. So the Cloud Native Special Interest Group, or SIG, is something, a group that we founded in this July. And you can find there the URLs to where we explain what the objectives are, where we meet, and where to reach people in the group. We have also a chat in Gitter, where you can send us questions and inquires about what we are talking about in the next meeting, whether the next meeting is going to happen, and so on. And the objective is to talk about what cloud native is and how we get there, right? How do we take Jenkins to this goal? We have a bunch of participants. I'm the lead in the group, and then we have participants from different companies. A long time Jenkins core committers, and also people coming new, so don't get afraid of participating. This is for people that want to run Jenkins in cloud, in Kubernetes, and like a more modern architecture, and we are open to hear feedback from you. And I'm really happy to show that we not only CloudBees is involved, but we also have people, and you saw them in the keynote today. We have people from Google Cloud Platform and from Microsoft Azure, and we are hoping to get more people involved from different cloud providers. So if you also are involved in some way on a cloud provider or somebody providing services or Kubernetes services, please talk to us, and we'll help you integrate Jenkins with your cloud solutions. So what the main areas are is pluggable storage, somebody will cover later, how to connect Jenkins with multiple backends for different types of storage, artifacts, blobs, and configuration and other things. What the cloud native is, which is a bit in the air, right, what cloud native is, but hopefully it's clear after this talk. And configuration as code, that there are other talks in this conference, but it's basically how can I configure Jenkins using code that I store in Git? How can I that way trace changes and have a history of changes, and everything is configured in Git? So all these good practices that nowadays are very popular, like configuration as code. So.
Yeah, so I'd like to talk for a little while about pluggable storage, and this is one of the areas where we've been pretty active in terms of development so far. So we have a number of pieces of this that are either shipping or that are works in progress that we're able to do some kinds of demos of. So to understand what we mean by pluggable storage, discussions about this have been going on, I guess, in the background for a couple of years at least, but they've taken on more urgency in the past few months, especially. Essentially, the problem is that currently Jenkins by default is going to store practically everything related to what it does inside this one gigantic directory on disk called Jenkins Home. So that includes all kinds of configuration, various kinds of runtime state, all of your build records, including metadata about them, files that they produced, logs from all of those builds, test results, fingerprints of files, like a whole long list of kinds of things. And this poses a bunch of problems operationally for people who are running Jenkins. I mean, first of all, you can run out of disk space, right? You might need to expand that volume. If you're unlucky enough to have this be on a network share, you're going to have definitely some performance problems in terms of transferring that. So there's a lot of scalability issues with it. There are also other kinds of, even setting aside scalability, there are other issues that people want easier access to this information in a direct format. They want to be able to run custom reports against all of this data using tooling that they already have that they're comfortable with in other environments. And right now, that's very difficult to do with Jenkins. You basically would have to write custom scripts that access Jenkins-specific APIs to pull out bits of information one at a time, and you can't get indexed access to those things, for example. So there are a number of plugins and various workarounds and techniques that exist in this area, but generally they fall into two categories. Either there's something that you need to opt into as part of your project, so it's something that's very visible to every developer. They have to use this special plugin in order to get a benefit. Or it's something where it's mirroring information from Jenkins Home somewhere else. So you get access to that information elsewhere for reporting, but you don't necessarily get any of the performance benefits. And this has been an architectural problem in Jenkins. So when we talk about pluggable storage, there's quite a list of things that we're referring to. So artifacts would be files that are saved as part of a build, except where that's covered by something else. So we're not talking about, if you're explicitly uploading to Nexus or saving to a Docker registry, that's another matter. You're not affected. But if you're using Jenkins built-in artifact management, you are. Build log, so just all of the text that comes out of your build, whatever it consists of. Configuration of Jenkins, job definitions, credentials, all of these things. So what do we want out of pluggable storage? First of all, if at all possible, we don't want to force developers to change their pipeline definitions or change their way of working in order to get access to benefits. If there's an obvious way that they should be able to just magically get stuff in the cloud, then we want to do that without having to have everybody search and replace. So for example, if you're using the archive artifact step, we want archive artifact some file to just work and save to cloud storage. You shouldn't have to use a different plugin to do that. In terms of scalability, any kind of large file transfer, we would like to, if at all possible, do from the agent side rather than from the master side. And this is to try to insulate the master from being overloaded by large numbers of concurrent builds, something Oleg and I talked about in more detail this morning. And we want to be able to, in fact, have information aggregated from multiple masters. So we don't want to have all of the files isolated in each master's Jenkins home directory. We want it all placed in a natural home on some cloud service. In terms of extensibility, what we're mainly doing at this stage is building the infrastructure in Jenkins core and foundational plugins such as Pipeline to make this kind of stuff possible, and providing reference implementations. So typically we'll focus on Amazon Web Services based reference implementations because it's a fairly popular platform and we can understand it in good depth, but we want other people to have everything they need to create different implementations for both on-premises services as well as other clouds. So at this point, the major piece of work that we have done is the artifact storage, which is now fully released, including support for Amazon S3 Blob Store. There's also some other people have put together a way of storing Jenkins credentials entirely in Kubernetes. So you don't need to have any secret definitions in Jenkins. It simply refers to Kubernetes secrets and uses them immediately with no further configuration. And things that are in progress in particular, we've highlighted in yellow, and I'll go over information about a couple of those. So first of all, about artifact management. This was done as part of Jenkins enhancement proposal number 202. I think there's a talk about the JEP process and how these things work. This basically set up all of the infrastructure needed in Jenkins for plugins to add these external storages. So we've released a particular implementation for Amazon S3. This has now also been integrated into the Evergreen project so that if you're running in the AWS environment, it comes pre-configured with the S3 support out of the box. So that means that if you just run Evergreen in AWS, you can go and copy-paste an example pipeline using artifacts from our documentation site, and it should just work. Credential storage, the API in this case has been available for a long time, but there is a relatively new implementation, as I mentioned, for Kubernetes. CloudBee's core product also includes an analogous implementation for CyberArk for people who are using that system. You can imagine that there could be other implementations for other secret stores. Configurations, when we talk about configurations, typically in Jenkins, these would be the long, the directory full of little XML files, each of which has a few configuration fields in it. And these are things that we would like to be stored in some sort of fairly lightweight configuration store. There's some work in progress to perhaps store this in Kubernetes resources or in a SQL database. So there are prototypes underway here. We'll talk a little bit more in depth about logging because this is a more complicated case. And in particular here, I'm talking about build logs rather than other kinds of log output that's generated by Jenkins, like the administrator system log. So how a build log works in Jenkins in currently released versions of software is that the master is entirely responsible for the full text of the log. It stores it basically in one long file on disk underneath the build directory. And any output associated with that build has to go to the master. So even if you have an agent that is running a 3-hour-long build with 100 megs worth of detailed debug output, all of that text winds up getting streamed over the single channel that's also used for control messages. goes onto the master, and then the master has to flush all of that stuff to disk. So this is definitely a bottleneck in the architecture. So what we've done for external build logging is make it possible for Jenkins to know about an external log storage system. We have a couple implementations in progress using Elasticsearch Logstash as well as Amazon CloudWatch logs. But again, these are more examples of the concept than anything else. And in this case, it's set up so that any log output which is produced by a process running in an agent machine is going to get streamed to the log service directly from that machine. So it never has to go through the master, the Jenkins master at all. So that cuts back on quite a bit of disk I/O, network I/O processing, and so on the Jenkins master side. If and when you actually want to look at the text of the log, and that might be never, because if you have a successful build, something gets deployed, you have a green check mark in GitHub, why bother? But if you do want to look at it, then then there are a few options. Either you can have some sort of browser that runs directly against that external log store, or we can also display that text from the traditional Jenkins web UI, in which case we have to load it onto the master then. But at least that's not done in every case. So this involves a number of different, somewhat tricky changes. There's some changes need to be made to pipeline plugins to support the proper mode of streaming that we needed for this. And in order to get full support in Jenkins, including for freestyle projects and so on, there's also core changes that we have in progress to make this possible. We have, as I mentioned, a couple implementations that we're using as reference implementations for to eventually become products and or to serve as demonstrations for people writing their own implementations. CloudWatch logs, perhaps via FluentD, that's still to be ironed out, and Elasticsearch Stack. Test results are another case of something that, depending on the project, can be very significant. So sometimes people do have builds that produce thousands of test result statistics from a single run. This is all something that we would like to be stored in an appropriate kind of database, whatever that might turn out to be. And again, if at all possible, we'd like the upload of all of the details to be done directly from the agent without having to involve the master in it. So from the perspective of your pipeline, you run the JUnit step, which collects whatever kinds of test result data you have. And it marks your build unstable or not. It gives you some summary statistics like 38 tests skipped, 2 failures, 6,018 passes. But if you care about any of the details, they're available in an external store. And if you do happen to use the traditional web browser for it, the traditional Jenkins web UI to browse it, then we still be able to provide the same UI as now, except going through a proper database instead of a dozen bloated XML files. So similar cases for code coverage. There's a new code coverage API that provides sort of an integrated version of different kinds of code coverage tools. And Uli Hafner has a session. I think it's coming up. I'm not sure if it's today or tomorrow, but I think tomorrow. He has a session coming up about rewrite of all of the static analysis plugins that he's working on, and that's something that we would hope would converge towards this kind of model in the future as well. As part of the special interest group, there's a whole page with all kinds of details on the status of various pluggable storage stories that we have. As I said, Artifact Manager and external credentials can be installed right now in the production grade. Build logging is something we're actively developing. Just started working on test results and other things we need to prioritize at this point. If you'd like to get more, then please join our SIG.
Okay. Yeah, and the next part is Ephemeral Jenkins. So Carlos will make a short introduction. What has happened? Okay, do you need a clicker? Okay, so Carlos will make a short introduction how we see that, and then we will talk about tools and show a demo of Ephemeral Jenkins. So yeah, stay tuned.
Yeah, so one of the reasons we are doing this, right, is if you read the Kosuke's blog post, I like one of the phrases there that is like, Jenkins has reached a local optimum. So it's like we want to leave the comfort zone, use the new tools that are outside, new technologies, new stacks, things like Kubernetes that didn't exist like 4 years ago or 5 years ago. And we want to make sure that Jenkins is the tool of choice for CI/CD in these new platforms. And what we want to achieve are things that today seem for somebody that is totally new or doesn't know Jenkins at all, but comes from Kubernetes or new technologies, new stacks, things like infinite scalability, right, is something that is kind of possible today if you architect your things right. Having multi-tenancy, multiple Jenkins builds happening at the same time without interaction with one another, one plugin not killing your master and then screwing everybody's builds, right? That's one of the things that we're trying to achieve. And pay-per-use. And everybody's aware of how operational responsibility, how big your machines have to be to run Jenkins masters, that if you're not running any builds, you are paying for that anyway. So we want to something that works with the scale to 0. I don't run any builds, I don't pay anything. I run 1,000 builds, I pay for 1,000 builds, right? So also we want a highly reproducible environment. We want to use Docker and containers for everything that is built in Jenkins. And we want to use configuration as code and like the configuration of your build, the Jenkins file, stored as code in Git, so you have traceability. Configuration as code to supply YAML files that will define what plugins, what versions you want to use. And allow canary upgrades, so whenever you upgrade Jenkins, you can see whether the new version is breaking some of your builds or not, and be able to roll back easily. Minimal operation costs related to pay-per-use, and no need for you to provision file system like today with a Jenkins master. No need to pay for that storage or for that CPU. No need to have to be doing backups of your file system. And overall, we want to treat Jenkins and your CI/CD environments as cattle, not as pets, like they are today. And in these platforms like Kubernetes, it's very reasonable, or it's reasonably easy to run highly available environments, and we can replicate these services running, and also have a more simplified and secure by default model. So all these things are stuff that we want to achieve with Cloud Native Jenkins. Now, how are we going to do that? We are looking into Ephemeral Jenkins. Is something that allows you to run single-shot masters and single-shot agents using a project called Jenkins File Runner. And I'm going to demo that. That combined with Pluggable Storage, where all the results of your builds or your deployments is stored in cloud services or Kubernetes services, and the static configurations with config as code in YAML.
Okay. It seems to be a bit old version of slides. Okay. So you may ask, how do we build this ephemeral Jenkins master? And the good news is that you can potentially build it even now, and we spent some time prototyping it, and that's what we are going to show. So the idea that we go to Kubernetes or go to Docker, we package Jenkins master, as Carlos said, in a Jenkins file runner. Everything is externalized, and there is external event handler like Pro or whatever, which receives webhooks, schedules tasks, returns results. But our system is single shot, so each time we can complete the build, we can remove this Jenkins port with our master, because all the data goes to pluggable storage. And we still have access to this data if we want to display it somehow. So how to build this system? Actually, all tools are in place. It's not only a Jenkins file runner. There is configuration as code. There is a number of core plugins. And we created a new tool called Custom Work Packager, which allows to glue everything together and build Docker images which are ready to fly and include everything. So configuration as code. Actually, there are two ways to do configuration. One is Groovy init scripts. It's something old but widely used. 1 week ago, there was a new configuration as code plugin released. Nicola and Evelina are going to present it tomorrow, I guess. This is one of the new ways to configure everything in YAML. And also there are features in Docker packages like plugins txt, Java Flux, etc., which you also can configure in your configuration flow. But now you need to somehow run these things. And there is a project originally started by Kosuke and then extended by Nicola. It's a Jenkins file runner. So it's a tool which can take a Jenkins file as input, execute it, and die. So this is the single shot master. The only problem with this tool is that somebody needs to produce the image which would include everything together. So there are multiple ways. Many of you have already created your custom Docker images using official one, included configuration as code there. And actually, you would be able to use such approach, then maintain it. And yeah, it would be a way, and many people select this way. But there is alternate solution. So in order to enable and simplify that, we created Custom Work Packager. And what this tool does, actually, it takes another configuration YAML, which allows describing the entire system, including plugin lists, components to include, configuration as code, scripts, system properties. It takes everything and bundles it to ready-fly executables. It may be Jenkins Word file, Docker image, or now Jenkins file runner, starting from the recent versions. So using this tool, you can create an image. And then when you create this image, you just run it. And everything is embedded. So configuration as code is inside. It's being deployed. Plugins are inside. There are performance tweaks. So this Jenkins master starts in a few seconds and just starts executing your pipeline. So, and so if you want, there is a public demo which you can open and try this solution. But yeah, now we want to present something which combines with pluggable storage and make it ephemeral Jenkins. So, Carlos? Okay, yeah, demo.
Let me. Okay, so what we have here is a Kubernetes cluster. Let's see. And we have a Jenkins file that uses also the Kubernetes plugin. So I'm defining run my Jenkins file with two containers. Well, one is the JNLP Jenkins agent container that you always need. It's a custom version, so we explicitly specify it. And then another container is just Maven. Mm-hmm. And I have a very simple Maven build that checkouts my Git content, using secrets, using credentials that I have stored as a Kubernetes secret. And I have inside my container Maven, I just do a Maven package, and then I said archive my artifacts, well, the jars generated by Maven. So this is my Jenkins file. And in in here, we have the packager config, which is the custom word packager configuration. It's a bit verbose today. We have, well, basically what Docker images to base on, what tag do we want to use for the generated Docker image. And we have a very long list of plugins that we want to include in this image because we want to bundle pipeline, we want to bundle the Kubernetes plugin, we want to bundle the Kubernetes secrets, credentials manager provider. So we have a bunch of plugins here, and we can also specify system properties, and we can also pass a file that defines, is being used by configuration as code plugin to configure this Jenkins master when it starts. You can also pass Groovy scripts and a bunch of other things. I don't know if I'm forgetting something.
Many feature flags, for sure.
So what I do here, I have, well, I'm going to create, I'm going to start with make, Kubernetes. So I'm going to, this is deleting some of the old stuff and creating the new things. So what this demo is doing is copying the Jenkins file as a config map in Kubernetes. So my Jenkins file is basically created as an object in Kubernetes. And then I'm launching a job that, Kubernetes job, that is going to use the Jenkins file runner to start a new Jenkins master, read that Jenkins file, and execute it. So while this is starting, I can see the logs. These are your normal job logs that you would see in the Jenkins UI. And while this is starting and doing the Maven build, I'll show you, I was going to show you here, not here. So this is the job I have created in Kubernetes, the Jenkins file runner. It uses the image that the custom word packager has built, and I'm passing several properties just to make it work for the demo. But it's fairly easy. It's just a Kubernetes job that will use the config map. It will use the secret I have created, and it's going to run everything. And let's see. Oh, it has finished already. You can see here that it has downloaded the internet with Maven, and at the end, building the jar, and it has archived the artifacts. And you see here, uploaded one artifact. I haven't put anything specific to S3 or any custom implementation in my Jenkins file, but my artifact has been uploaded to S3 automatically, because in the config as code file, I'm saying use my artifact manager, the S3 provider. And I'm also saying use this S3 bucket and this directory inside the bucket. And this is the configuration as code file. If I go to AWS, before we had this artifact was 112. This should be now the new time, 303 is when it was built. So it's there for me to use whenever I want. And if I go to CloudWatch logs, Kubernetes, Jenkins file runner, I can see all the same logs that I've seen in the console are stored in CloudWatch for me to use in whatever way I want. So you can see all this downloading Maven stuff from here. Okay, anything I'm forgetting?
Yeah, we have a few slides left, I guess. Yeah. Okay, so. Yeah, so what is the advantage of this approach? Actually, this is a schema of our demo. So yes, we use Artifact Manager. We also send data to CloudWatch by using system things. Today, we had a presentation with Jesse where we used Fluentd CloudWatch plugin, which does the same via Pluggable Storage without Jenkins file runner. And the main advantage of this approach is effectively if you have system which needs different plugin sets, which needs different configurations, you can just create as many Docker file runner images as you want with this tooling. You can create continuous delivery tools for these images, and then your system can just take the images it needs and execute your builds. So you get lots of options for configuration management with such approach. So far, it's our vision of cloud-native Jenkins. And of course, there are a lot of stories to happen before this Ephemeral Jenkins and cloud-native Jenkins come to production. Lots of stories can be delivered early, so it's not a kind of big bang release at some point. It will be a gradual change. The stories we want to work in cloud-native SIG is, of course, external log storage. We need to finish them in order to make the plugin generally available in update centers. There are test results, configuration storage, which is also a work in progress. Then in SIG, we also work together on configuration as code together with JCask team. And we will continue our research towards cloud-native Jenkins. And of course, there will be a lot of alignment with JenkinsX and Jenkins Evergreen teams, which also work towards the same direction. Okay, so if you're interested to talk, to know more, yes, tomorrow there will be a presentation about Jenkins configuration as code. Come to this presentation, you will know much more about these YAML files which we were showing. Then about JenkinsX and about cloud-native Jenkins, yeah, there is a lot of talks, and at one of the talks, they will be also presenting JenkinsX 2.x work, where they use pretty much the same toolchain we created, so that, yeah, there is already some alignment between the projects we have now. So, regarding takeaways, so if you have AWS, you can already try Artifact Manager. You can, if you use Kubernetes, you can take credentials, storage, etc. And please follow Cloud Native SIG if you're interested in this area, because yeah, lots of stuff is under development. We have regular meetings, and we are ready to collaborate. So yeah, every few weeks we have public meeting. Everybody can join, provide feedback, share his needs, and we are ready to discuss how to approach that. And obviously, if you want to try existing implementations or if you want to create something new, this SIG is also an opportunity for you to contribute and to get some information. So it's a public venue where you can discuss everything. There is some links for our talk, and yeah, if you have any questions, we are happy to answer them. Okay, just raise your hand if you have a question.
Ask us 2 questions. Yes.
Okay.
Based on this, where's the GUI? Is it available as an option?
Okay. So the question is, based on this, where is the UI? That's a great question. Next one. No, just kidding. So we are going to start without the UI for the serverless Jenkins, because we think there is a lot of people that don't care about it that much. So we are looking at, if you look at how JenkinsX works, where a lot of the, or most of the interaction happens in GitHub pull requests or GitHub issues, we are looking into that model as initial solution, where your pipeline will go to GitHub and say, the test has failed and this is the failure, more than the test has failed, go here to some UI and look at it. Mm-hmm. We are considering and we are looking for feedback from people. I mean, we could also generate an HTML report of test results and upload it to S3 and serve it from there. There's plenty of options to do things like that.
Yeah, right. There is also a pluggable storage installation. So if you have your own services for browsing data, then you can use these services, and they give a kind of UI. And a lot of compatibility stories will be based on the feedback.
But this is for serverless Jenkins. For the other, yeah, for the pluggable storage, you can still use today's Jenkins and UI.
Right.
Right. Yes. Yeah, so where is Jenkins X and Cloud Native Jenkins comes together? Yes. So we are merging some of the efforts, and then Jenkins X kind of becomes the solution for building Kubernetes applications. But a lot of what Jenkins X has today is part of what Cloud Native Jenkins, of the Cloud Native Jenkins story. Things like the Kubernetes credentials provider, it's being already used by Jenkins X. But yeah, there's not gonna be a disconnect. It's gonna reuse the same bits.
Okay.
So what's the workflow if I make a code change to my source code and I want to build it and produce artifacts? How does that work now that there is no UI, there is no job?
Yeah.
For somebody to say, okay, run B, or there's a webhook that goes back to you.
So what's the workflow today if I wanna build something, right, and produce an artifact? So there is going to be a webhook handler, and Jenkins has already demoed some bits here, that is gonna receive the webhook from your Git provider, GitHub, or whatever the Git provider you use, or any other. That event processor is the one that is gonna start a job in Kubernetes, and that job in Kubernetes is gonna start a pod with your serverless Jenkins, and that's what's gonna go through your Jenkins file and do something. That something could be archive your artifact.
Yeah, just to build on that a bit, I think this is an example of a case where something that today is built into Jenkins as a Jenkins-specific function. So for example, branch indexing and creating a list of all of the branches and counting build numbers within each job and creating that tree and handling the webhooks from GitHub. So a bunch of that logic in this scenario would be moved into an external pretty small service that just that is listening to the GitHub webhook and is starting the build. And so that would replace some of the traditional functions of Jenkins.
And I guess that service will run in a container somewhere or some
Right.
Yeah, but the goal is that that service runs separate, and that service can be scaled, and that service is not a single point of failure anymore. Yes. Yes.
So the demo you guys just gave basically is for single shot mastering, correct? And I noticed on the slide you had something related to multi-masters, so possibly like clustering or something. I was just wondering if there was.
Okay. Yeah. So there is the idea. So we don't think serverless Jenkins is going to fit everybody, right? And we don't try to make it so everybody uses that. So there's going to be some improvements that are going to be retrofitted or reused by current Jenkins. And if we get pluggable storage to a place where you don't have any data in your file system, then you could easily run Kubernetes with multiple replicas of your Jenkins master. So that's one of the things about multi-master. Yes?
How does this fit in with the Kubernetes Jenkins plugin that is already out there and being used, in which case you have a master that just accesses the Kubernetes to bring up pods from individual slaves? Are these related at all?
So how does this relate to the Kubernetes plugin? In this demo, this was still the Kubernetes plugin use. The Kubernetes plugin is to create agents running on Kubernetes. What we show is also the master running on Kubernetes. So this could use the Kubernetes plugin to run your master and agents on Kubernetes, but we are also looking on how to get rid of remoting and making it more native Kubernetes solution in a way that maybe your master runs in the same pod as your agent, and there are two different containers, and they just talk through the Kubernetes APIs, or your master starts, and then the master starts new pods, and those pods get also managed with the Kubernetes API.
If you want to know more about networking, today on the morning we had a talk about scaling Jenkins network. And please feel free to come to the contributor booth, so we will be able to share some context, show how it would work. Maybe getting rid of remoting is a bold statement, but who knows? So yeah, there are lots of things to discuss, and yeah, we will appreciate your feedback. Oops. Okay, so yeah, I guess we go to the contributor booth.
Yeah,
Anyway.
if we'll be outside, so if you want to ask us more questions, we'll be outside. Thank you.
Okay, thank you.